So Sara is going to be talking to us about Comet NEOWISE and investigations of that were revealed by observations of the upgraded NIRSPEC. So,
yes. Can you hear me?
Yes.
Perfect. Okay, so thank you very much for selecting our work, since it's one of the few solar system work related. So I'm gonna show you the results that we had in Comet NEOWISE and as revealed by NIRSPEC2. And I'm gonna start saying why we're so interested in studying comets. And that's because basically, of course, the importance of studying comets is related to their astrobiology relevance, because those objects are believed to release water and organic materia on barren planet, and in some way enhancing the chance for life to be originated. But when we actually are looking at comets, cometary ices in their lives experience very different processing. So they retain information from the prestellar and interstellar medium processing in their ices, and then during the formation and the storage and then the history, so the evolutional processing that they experience, they actually experience different processing that are stored in some way in their ices. So when we are observing comet, one of the first questions that we can ask is like, how can we test their cosmogonic origin, and how can we understand if those objects deliver water and organics, and which kind of water and organics they deliver on our planet? So basically, we had these three parameters that we can investigate, which are sort of cosmogonic parameters, like parameters that do not change in time, that we think remain sort of immutable. Those are isometric ratio, mixing ratio, and isotopic ratio. And those are kind of related to the formation processing or the storage processing that these ices experience. So we are going to expect, for example, to have low deuteration with high temperature formation region, or to have a great organics complexity in very cold formation regions. So to go to our comet, we actually been awarded of directory discretionary time, and I want to thank the director and also John O'Meara to support our project. We actually asked time, and we got time in a few days. It was great. We observed this incredible comet passing close to Earth on 4th of August UT time and 6th of August UT time, when the comet was around 0.9 astronomical unit heliocentric distance and geocentric distance roughly. You can see in this slide the orbit, the top view, the lateral view here on the right side. You can see in the center our configuration of observation configuration, where we put the slit and relative to the sun direction and the orbit. And here in the right panel, you can see the visibility chart. So you can see that we observed the comet just right after sunset, and we followed as soon as as much as we could before it was setting. And in this picture here, you can see the slit position on our object. We investigated the KL setting, 64.2, 33.1, and we had actually observation from around 10 minutes on source for the first night and 24 minutes on source on the second night. We sampled the order from 21 to 27, and you can see here in black and white, these are the emission line that we have been detected in this comet. So basically, we crop and extract all the spectral order. We spatial and spectral straighten them. And of course, we flux and frequency calibrate them. And here you can see two examples, order 23 and order 26, in which we detected ethane, methanol, methane, and also water and ammonia. Basically, you have the frequency on the x-axis, you have the flux density on the y. On the top, you can see the spectra of the comet. You can see on gray the fitting of the continuum fissure with all the absorption from the telluric contamination. And once we subtract that, we can actually model the emission line with our quantum mechanics fluorescence model. So for ethane, methanol, and all the organic species. So now I can just report to you the quantification of these modeling, telling you some numbers, but then tomorrow you forget them. So I'm gonna just show you the cosmogonic parameters, so the results of these investigations. So basically, what I'm gonna show you is the first one, which is mixing ratios. So from all the extracted production rate, molecular production rate for all the organics and water that we achieve, we basically build this kind of chart, which is the related abundances of all the molecules of all the organics relative to water, and we scale here to the reference Oort cloud value in Oort cloud comets, of course. So we scale to the unity for comparison. So the first thing that you can see, I compare the Keck data, which is the yellow star, with the ice shell data of a few weeks earlier, and they are pretty much in agreement. You can see interesting chemistry here going on, because those molecules are aligned from the less hypervolatile to the more hypervolatile. So you can see that we have an enrichment in acetylene, ethane, and methane, which might be an interesting information about the hydrogenation reaction on grain surfaces. But also we can see an enrichment in ammonia and HCN. And those, if we compare this information with the spatial profile information, which is another part of our work, and we are working on that, we might gonna extract information, and these two molecules are coming from probably the dissociation of refractories in the commissary coma, like for example, ammonium salts. So just from the mixing ratio, we obtain very interesting results on this object. But also we perform deuterated investigation. And here our first deuterated investigation results. So we've been trying to detect HTO. Of course, with only 10 minutes on source, it was pretty tough in the first night. With 24 minutes on source, we obtained a preliminary results of a 3 sigma upper limit of about less than 6 times Vismo, where Vismo is the reference value for our planet, for Earth, which is 1.55 times to the minus 4. And so basically here you can see order 21, you can see the spectra that we extracted and the fitting. So we don't have a detection, but we have this 3 sigma upper limit. Usually in comets, the range is between 2 and 3, so it's not really a significant value, but as preliminary result, it's pretty substantial. The other investigation that has been done is on deuterated ethane, which is one of the first measurement that has been performed in a comet so far. So you can see again the order 23. You can see the spectra, the beautiful spectra, high signal to noise for ethane. We also run the deuterated ethane model, and here we also find a preliminary result of 3 sigma upper limit of less than 22.7 Vismo. So this value, it's more significant, I would say, relative to the water one, since for organics, the deuterated value, the average value, it's greater than for water, it's higher than for water. And it's actually, there's gonna be, of course, further investigation and comparison with also other value, like for the interstellar medium value and other comets, for example, organics value, like for methane, for example. So running to my conclusion here, so this has been a great investigation in this unique object, unique comet. We obtained a very interesting chemical composition results. We saw an enrichment in ammonia and HCN. We saw enrichment in acetylene, ethane, and methane. We attempted detection of C2H4, which would be the first one in a comet, but we're still working on it, and I'm not gonna mention any more detail. And we had deep deuterated investigation in this object. And as I mentioned to you, we had Vismo, 6 times Vismo value, less than 6 times Vismo value for water, and less than 22.7 times Vismo value for ethane. And again, this was with a few minutes on source. Also, the comet had a figure of merit, which is a parameter that it's a kind of related to the activity of the comet, that was not that high as we were expected. So with more active comet and with close heliocentric distances, and of course with longer time on source, we are certain that we can achieve also more significant results for the average in water. Of course, future observation will be also to detect and try to attempt detection of deuterated methane in the K2 setting. So with this, I thank you for your attention, and I also wanna mention to check out the poster session for more cometary science with NIRSPEC2.
We have time for a quick question, if someone has one.
Ooh.
We're waiting for one to come in. As the instrument program manager at Keck, I have an idea about other instruments and wondering if more simultaneous wavelength coverage could have helped you with your observations.
Yeah, I mean, with NIRSPEC, we could also investigate the N band for sure. That would be very interesting. So we can investigate the CO, for example, and other species that are emitting the N band. Of course, that would be great. I would say that probably low resolution spectrometer, they can give us information about the dust component, so the nucleus and the ICs. So that would be a nice addition to be complementary to our high resolution observation for sure. Yeah. Okay.
All right, so let's turn any other questions that are for Sarah over to the Slack line, and we'll move on to the next talk.